All right, guys, this is our very last lesson of the year for our Unit 6, Part 3. So we have graphed just about every quadratic equation you could possibly think of. So now we're going to just talk about what happens if you have two graphs or two equations on the same graph, right? We've done that before when we had two lines. We had a system of equations, and I know that was a long time ago, but we're going to bring it back up into your memories right now. So it's when we put more than one equation on the same graph. How do we find those solutions, right? So when we have a system, but we're not going to get too crazy. We're going to just look at when one of those equations is a line and the other one is a quadratic. If you have two quadratics, all kinds of crazy things can happen. So we're just going to focus on the basics when you have one line and one quadratic. And we're going to look at how do I find those solutions to those systems by looking at a graph. And we're going to talk about how do I find those solutions using algebra, so using the equations. All right, so the best way that I thought to help you kind of see what's going on in these is to do a little bit of a review right next to something new. So looking back at what we did way back in Unit 3 with our systems of linear equations and comparing it to what we're going to do now in this unit where one of those equations is a quadratic equation and the other one is a line. So if you look on the left here, the blue column is review. This is what we did back in Unit 3. So this was Unit 3. All right, so these are my two lines. So my first line is y equals 2x plus 4, and I did all the work for you. I found m, I found b, and I graphed the whole thing. So there's that line right there. And the second line was y equals 1/3 x minus 1, excuse me. So those are my two lines, right? And so hopefully you remember when back in Unit 3, if I was trying to find the solution to that system, I was looking for the point where the lines intersect, right? That point would be the point -3, -2. Point where they intersect, right? Because those are values, that's an x and a y value that works for both equations. If it's on the green line, that x and that y work in the green equation. If it's on the yellow line, that x and that y work in the yellow equation. And I'm looking for that set of x and y's that work in both. So that's the point where they intersect. Now, if I look over here on my new one, right? My new idea is like I have a line, right? So this bottom equation is a line, no x squared in that one, just an x. But my top one this time is a parabola. This is my quadratic. So the idea is the same though. When I'm looking at the graphs, I'm looking for the point or points maybe that work in both equations. So it's the point where they intersect. That's still the solution because if it's on that yellow line, it works in the yellow equation. If it's on that blue parabola, it works in the blue equation. So for this one, my point would be the point 0, -3, right? But the idea is exactly the same. You're just looking for those intersection points. All right, so now when I think back to Unit 3 in my review, I had some interesting situations, right? We definitely had the ones where they intersect in one point, but I also had some different ones. I had the ones where I had one equation, 2x plus 4, and I had my second equation, which was y equals 2x plus 4, and I'm looking for that point or points where they intersect. Well, these overlap all the time. Hopefully you remember what that means. This was an infinite solutions, right? Every single point on that line is an intersection point. They're crossing at all of them. So all of the points on the line are solutions. So we did have that situation when I had two lines. Now, if I have a line and a parabola, is that ever going to happen? No, because my line has to be a straight line and a parabola has to have that U shape. So I'm never going to have a situation where, oh, maybe I'll switch these, where my line and my parabola overlap all of the time. So it's just not going to happen. But I could have this situation where as I follow my parabola and look where it's intersecting with my line, let's see. do I want to do here? Oh, I can use green. I have this point right down here, the point -1, -4, but I also have this point right here, my point 1, 0. So this one has two solutions. So that can happen when I have a line and a parabola. I can't have an infinite solutions because they'll never overlap all the time, but they could overlap more than one place. So this one was only one solution, right? They touch in only one place, just like that pair of lines. But this one has two solutions. Could I have more than two solutions? Well, picture moving that yellow line. If I slide that yellow line up and to the left at all, maybe it lands here or here. It's still only going to hit in two places, right? Yeah, those places are going to be farther and farther spread out, but there's no way that I could curve around and hit in more than two places. In fact, even when I do that, I'm still only hitting in two places, right? So the only way it could happen is if it kind of did one of these, but that's not a line. So there's no way to have more than two solutions when I have a line and a parabola. So I can't have an infinite solutions. I can have one solution. I could have two solutions, but I can't have more than two. All right, but there was one other interesting situation when I had two lines, right? Here was my original to y equals 2x plus 4, and my second one was y equals 2x minus 5. So if I remember that situation, I'm looking for where those two lines intersect. Well, these parallel lines, these have no solution, right? Since they have no solution, they don't intersect anywhere. Well, could that happen when I have a line and a parabola? Well, here's my line. Here's my parabola. I maybe have to be a little more careful when I highlight my parabola. But yeah, they're not touching anywhere, right? There's no points where they intersect. So we definitely could have a no solution here too. Now we would not call those parallel because one's a parabola and one is a line. So they're not parallel, but they are still no solution. So you can kind of see the similarities and the differences with two lines compared to a line and a parabola. The idea is the same though. You're looking for the points of intersection. Sometimes it's going to have one point of intersection. Sometimes it might have 2 points of intersection. Sometimes it won't have any, so it would be a no solution. Okay. So now the question is, what do I do if I don't have a graph? So we're going to solve this using one of our two other methods. So you remember, if I look at number 1 from my review, so over here on the left in my blue column, this is from Unit 3, right? I have 7x plus 8y equals negative 22, and I have y equals 3x plus 5. So if you remember back from Unit 3, we had two algebra methods that we could use that weren't graphing. One of them was substitution, and one of them was elimination, right? Substitution is where you had that x equals or y equals. Elimination is where you had the opposites, right? This is where I was looking for x equals or y equals. This is where I was having the opposites with one of the variables. Helps if you can spell opposites. There we go. Where when I added the equations together, that one variable would cancel each other out. So if I look at what I have here, and what's probably going to happen quite a bit when I have my new ones over on the right, which we'll get to in a minute, is most of the time we are going to be using substitution, and that's definitely the case in this first one because I have my y equals, right? So if you remember substitution from back in Unit 3, I look for my equation that says x equals or y equals, and I plug the rest of that equation in for that variable in my other equation. So I'm going to plug the 3x plus 5 in for y into my top equation. So this would be 7x plus 8 parentheses 3x plus 5. So I have replaced the y with the 3x plus 5, and then finish it out to say equals negative 22. Hopefully this is looking familiar to you. I'm just going to go ahead and keep on solving. So I distribute my 8, 7x plus 24x plus 40 equals negative 22. Combine my like terms here. 31x plus 40 equals negative 22. Subtract 40. I get 31x equals negative 62. And I divide both sides by 31. So I get x equals negative 2. Now remember, I'm looking for the point where they intersect, right? So my answer is a point. I have just solved for x, so I put that negative 2 in the x spot, but I'm not finished, right? I need to solve for y. Hopefully you remember that you can pick either one of those two equations because this point should work in both of them. And plug in the x to solve for y. Now the bottom one is definitely the easier equation to plug into, so it'll be y equals 3 parentheses plus 5. So it'll be 3 times negative 2. So I'm going to take that negative 2 that I just solved for, plug it in for x in that bottom equation. So I'll have y equals negative 6 plus 5, which gives me y equals negative 1. So my solution, negative 1. My solution to that system, that review, right, was the point negative 2, negative 1. So that's when it's two lines. Neither one of them had an x squared, but I look for the x equals or the y equals to use substitution, plug it into the other equation. Now, if I look over at number 2, now this is new because one of those equations is a quadratic. I can see that squared in there, right? The process is the same. Like I said, I'm most likely going to be using substitution here because when I have one of my equations with an x squared or a y squared, then elimination is going to be really hard to do. So in this case, I'm just going to say, all right, I see that I have a y equals in my top equation. I'm going to plug that in to the bottom equation. So I'm going to take that x plus 1 squared and plug it in for the y in my bottom equation. So it's going to say x plus 1 in parentheses squared equals 16. You could think of it as the other way around too. It really doesn't matter which one you plug in since they both say y equals, right? Since they're both y equals, it means they equal each other. So whichever order you want. Now, I know a lot of students, when they get to this point, they see that squared and they want to start distributing that exponent. Remember, you can't just distribute the exponent because you've got the plus sign in there. So if you were going to multiply this out, you would have to FOIL, right? X plus 1 times x plus 1, FOIL the whole thing, or distribute. But look, the squared is by itself on this one. I'm going to save a ton of time and remember all my different ways of solving quadratics from the last unit. And I'm just going to say, hey, that squared is by itself, so I can get rid of that squared by doing a square root right away. So this becomes x plus 1. Remember, what times itself gives me 16? Could be positive 4, or it could be negative 4. Now, I know there's a lot of different ways to write that. You could write plus or minus 4, but be careful because that means you have two different answers. You could write two different equations here. X plus 1 equals 4, x plus 1 equals negative 4. I know that's a common way as well. Just remember you should have two answers now. After you take that square root, the next step is positive or negative. But now I need to subtract 1 from both of my possibilities. So I get x equals positive 3. And I have x equals negative 5. Now remember, I'm looking for points where they intersect, right? Since I have two different x values. Those are not the two numbers from the same point. That is the x value for one point and the x value for the other point, right? So I need to actually go ahead and plug in each of those so that I could find my 2 points. So I have x equals 3 as one possibility, and then I have x equals negative 5 as my other possibility. See, I took each one, and I'm going to make its own separate equation. Now, the only interesting thing about this one is this bottom equation, y equals 16, right? So in this case, okay, well, there is no x, so I'm just going to plug in the y must be 16, right? So I could just skip straight to that. So it's 3/16, negative 5/16. Boom, done. Or, I mean, technically you can plug into either one. So if you want to see how it would work, you could say, all right, well, that means y equals x plus 1 squared. If x equals 3, that would be y equals 4 squared, which would be 16. Or you could say, all right, same thing if I had x equals negative 5. It was x plus 1 squared. So that would be y equals negative 4 squared. Notice it's in parentheses, which would be 16. Either way. So that's the idea here. It's the same process. It's just that you're going to have to solve with one quadratic. All right, so let's take a look at this one. So no more review. Now it's just one quadratic and one linear equation. Notice the top one has an x squared. The bottom one has just an x. Again, I see that both are y equals. So however you want to think about it, I'm going to set the two of them equal to each other, right? I'm going to take that 6x minus 12 and plug it in for the y in the top equation. I'm going to take that x squared plus 2x minus 8, plug it in for the y in the bottom equation, whichever way you want to think about it. Okay. Now, I need to solve it. This time I have an x squared and an x. I cannot use a square root. If you remember back to that last unit, this is the whole point. This is the whole reason why we did that whole unit, right? So what I need to do if I have an x squared and an x is I need to get it equal to 0. I'm going to try and factor it if I can. Quadratic formula if I can't, but really hoping I can factor it. So I'm going to subtract 6x from both sides. I'm going to add 12 from both sides. I'm going to make sure I'm combining my like terms along the way. So I get x squared minus 4x plus 4 equals 0. Let's see, x squared minus 4x plus 4 equals 0. Now, if you need to use the factor box, you sure can if you use a factor box, right? If not, you can maybe just use that mental math idea, x squared on top, positive 4 on top, negative 4x down in the nook. That would be x times x. Negative 2 times and negative 2. Negative 2x plus negative 2x gives me negative 4x. Ooh, this was a bin squared, wasn't it? So really this is parentheses x minus 2 squared equals 0. Now this is one of those situations where I technically have two answers, but both of them are the same number, right? That's x minus 2 times x minus 2. So when I solve this, I set that factor equal to 0. When does x minus 2 equal 0? I add 2 to both sides, and I say it's when x equals 2. So this is one of those situations from my graph where I'm only going to have one point where they intersect. So we learned about what it looked like back in the last unit. We learned about what the graphs look like. So here's the idea of what it looks like algebraically, right? I know that x equals 2. Now I'm going to plug it into either equation. I think the bottom one is easier, so I'm going to go with that one. But you can plug it into either one if you want to. So plugging in positive 2 in for x. So I have y equals 6 times 2, which is 12. 12 minus 12 gives me y equals 0. It does happen sometimes, okay? So this is a situation where they only intersect at one place. If I just skip back to look at my graph, remember that would be like this top graph. They only intersect at one point. They're just like the other one. That's the idea, right? My first example is where they intersected in 2 points, like I have in this one. So remember that you can have either one. You can also have a no solution, right? We saw what that looked like, so don't be freaked out if you get that as well. All right, one last one here just to make sure you're really solid on the idea. Now in this one, they don't both say y equals, but I see the bottom one says y equals. So this time I'm going to take that x squared minus 16 and I'm going to plug it in for y in my top equation, just like we reviewed on that two linear equations one. So it's going to say 6x minus 3 parentheses x squared minus 16. Finish out that top equation equals 24. So I just replaced the y on the top equation with the x squared minus 16 from the bottom. All right, now I'm just going to go ahead and distribute. Now be careful, you are distributing a negative 3, right? Not just 3, but negative 3. So I have 6x minus 3x squared plus 48 equals 24. Okay, now I notice I have an x squared and an x in here, right? So I do have to set it equal to 0, so I'm going to subtract my 24 from both sides, but I'm also going to make sure that I have this in standard form so that I can factor it or use quadratic formula if I can't factor. So I'm going to switch the order. My x squareds needed to come first, so I have negative 3x squared first, then positive 6x. And now I'm going to combine these. 48 minus 24 gives me positive 24. Equals 0. So I hope that wasn't too much to do on you in one step, but I subtracted the 24 from the right so that it equaled 0, so I was ready to factor, and I made sure it was in the right order. Now you could go ahead and try to factor box this, but I'm noticing that there's a GCF going on here. Negative 3, 6, 24. I can divide all those by 3. In fact, I can divide all of those by negative 3. And since there's no x involved in my GCF, I'm just going to go ahead and divide it from each one so that I get rid of it and don't have to look at it anymore. 6 divided by negative 3 is negative 2x. 24 divided by negative 3 is negative 8. 0 divided by negative 3 is 0. All right, now that's a much easier factor box to do. In fact, I'm not sure that I really even need to do a factor box. I think I can do this in my head. What multiplies together to give negative 8 and adds up to negative 2? That would be x minus 4 and x plus 2, right? Negative 4x, positive 2x, add them up, gives me negative 2x, sure does. All right, now I'm going to squish that, kind of spread it out a little bit. I'm going to see if I can't get my last steps in here. Since I have two factors that are not the same factor, I have to set each of those factors equal to 0 in order to solve it. So I'm going to have one that says x minus 4 equals 0. So that means that x could equal positive 4, right, if I add 4 to both sides. And I have x plus 2 equals 0, which means x could equal negative 2. So here again I have 2 points for answers. So I have one of them which will have x equals 4, and the second one which will have x equals negative 2. Now I need to figure out my y's for each one. So the first possibility is x equals 4. And my second possibility is x equals negative 2. Now technically, again, you can use either equation to plug into. I think I'm going to use the bottom equation. I know it's the quadratic, but it's already set up as y equals, so I'm going to plug it into that one. So I'm going to plug in my 4 into the x squared minus 16, and then I'm going to plug in my negative 2 into the x squared minus 16. Start with the 4. So let's see. 4 squared, exponents would come first, so 4 squared is 16, so I have y equals 16 minus 16. Oh, I got another y equals 0. It doesn't happen every time, but sometimes. So when x equals 4, y equals 0, that would be 1 point. That's my solution. Okay. Now let's plug in the negative 2 and see what happens. All right, y equals negative 2 squared. Now be careful. Notice that it's in parentheses, so that would be y equals positive 4 minus 16. 4 minus 16 would give me negative 12. So my second solution is the point negative 2, negative 12. So again, 2 points as my answer, making sure that we plug in each of those x's into either one of the equations to solve for our y. All right, guys, I think after that you've seen all the possibilities. So just remember, solution to any system, whether it's both lines or a line and a parabola, is where they intersect. For a line and a parabola, it could be 2 solutions, could be 1 solution, or it could be no solutions if they don't intersect at all. When you're solving algebraically, you can use either of the normal methods, or substitution or elimination. I will tell you substitution is much more often. Just remember, though, you don't have zeros always as your y values. Once you get your x values, you have to plug back in to see what the y values are, or the other way around, right? So just remember, you're not finding zeros. You're finding points of intersection.